Hello and welcome to Sudoku. Here is a little killer arrow Sudoku by Qodec, the great author, often featured on Cracking the Cryptic, and I can't guarantee that this puzzle won't be featured on Cracking the Cryptic as well. And so these are the standard rules of little killer Sudoku and arrow Sudoku. So I think I go straight to the point and try to solve it. The first thing I notice is that the little killer clues point to digits they point to disjoint regions, disjoint groups of digits, and they all avoid those arrows. And something else is that those 4 boxes are completely covered by it. So what can we deduce from that? We know that the sum of it all, the sum of all those little killer clues and what lies on the arrows will be 4 times 45 plus those additional digits, which are 8 in total. Those three, and those ones. I just mark the additional digits in red. And now, what do we make of this? The sum along the little killer clues is that's 36, 67, 92, 103, 123. Plus 2 times the 4 digits, the sum of 4 digits, of those 4 digits, the arrow sums. This is 180, which is the total sum of those 4 boxes, plus 8 digits, meaning that 57 plus 8 digits is equal to 2 times the sum of those 4 digits, those ones. That's a real restriction, because those 4 digits, in theory, have a maximum of 18. That's if each one of them is a 9. So this is a maximum, the 4 digits has a maximum of 18, which means that this has a maximum of 36, and this has a maximum of 21. Oh. What? So sorry. No, that was wrong. So this has a maximum of 36, so this has a maximum of 72, and this has a maximum of 15. So red has a maximum of 15. Those 8 cells, and these have a minimum of 6, these have a minimum of 6, and these have a minimum of 2, which makes a minimum of 14. So there's only 1 degree of freedom. 1 degree of freedom, meaning that all of these arrows are either 8 or 9, with at least 3 of them being equal to 9, that these are 1 or 2. Oh, and they can't be both 1, because if they are both 1, then none of those digits can be 1, and the red sum explodes, being if those are 1, then those are at least 2, 3, 4, which make a minimum of 20, which explodes this. So these can't be the same, meaning that the theoretical minimum of 14 goes to 15, so there's no more degree of freedom. These are real 9s. Those reds are 1 and 2, and they are a 1-2 pair. And now those must be 1, 2, and 3, and because of this 1-2 pair, these digits must be 3s, and the other 2 must be 1 and 2. So that's a neat break-in. Not quite unusual. The unusual fact is that I found it straight away. Well, I guess such ways of reasoning have been around for a while. So that's a really nice start. And now I know that this won't be the end of the story. And what do we get? So we know we have a 1-2 pair, so this is at least 4. And actually, to complete this 9, we need 4-2 or 5-1. And I just synchronized our scenarios, meaning there is the left-hand scenario and the right-hand scenario. And here it's the same. For this 9, it's the same. So here we have 5 or 4, and here is 1 or 2. So we have 2 scenarios on how those digits resolve. And let's have a look at the other 9 sums, 9 arrows. So this is at least 4. This one is at least 4 as well. But it can amount to 8 with a 1 here, and then everything resolves. So it can be any number between 4 and 8, it seems. And the same applies to this. So what is the next place to look? We know that this plus this have a sum of 8. So those digits must not be that big. If this is 1 and 5, then this can still be a 4 with a 4. That doesn't seem so useful. This 15 needs another 12 without using 9, but it can be a double 6, it can be 5 and 7, can be 4 and 8, not that restricted either. This 31, this 31 is much more restricted, because we need another 30 or 29 without using a 9. So 87187 is a possibility. So that's one option. So it could be, for example, 78178 with permutations allowed between the 7s and 8s, or it could be a 2 with a 6-8 and a 7-8. I mean a 6-8 pair and a 7-8 pair. Or the other way around. 7-8 could be here, 6-8 could be there. So there's some degree of freedom around here. Not that much, but some. And what we put here has an impact on what this 15 is. It also has an impact on what remains for this 9 sum and what remains for this 21 sum. There's still a lot to do. So what do we know? This is between 4 and 8, and this is before 5 and 1, the other way around. Same for this. And then, should I explore some of those scenarios? Some would say, should I just bifurcate? No, that would be a search for elimination. Oh, sorry, I forgot that there is a 9 here. By playing Sudoku. This 4-5 pair may have some importance, but I'm not seeing it. What do we know about this 25? This is at least 4. This is at least 4 as well. That's already 8. This is either a 3 or at least 6. But I don't see all of that being so restricted. It's just that 6 digits must add up to 25, so that's an average value of 4 something, meaning that there must be numbers smaller than 4 in the sum, and such a number can't appear here, or there. Oh yes, there it could be a 3. Well, not sure that's the right place to look. What happens if I make this 7 and 8? Let's have a look. What happens if we take the first option? Is there any contradiction if I do that? If I do this, so I need a 1 here, which resolves all the ambiguities here, which disambiguates all this lot. Sorry if that's difficult to read. Now, what is available for this? We don't have 7, 8, but there's still 4, 5, 6, together with 5, 4, 3. That's really not a big restriction. Now, about this 12, or about this 11, we still need 8. This can't be 5, 7, 2. Five, 7, 2. What are the remaining possibilities? 1, 3, 4, 6, that's a lot. Not sure this is the right way to look at things. Oh, something I should have noticed with this. There's always an 8 here and an 8 there. So I can rule out 8 here. This is between 4 and 7. And I can rule out 1 here. This is between 5 and 2. It's not that much. But now I know there can't be a 4 here. I know that... What about this 21? I was thinking about this 25, but this 21 uses 6 digits. So that's an average value of 3.5. So there must be at least 2 numbers smaller than 3. And they can't appear here or here, nor there. Let's have a look. If I make this 3 and 4, say, let's say that's 3, that's 4, and we have, let's say 4, 5, 3. That's a total of 17, which is compatible with a 2 here, I think. No, it's not. Because here we have a 1-2 pair. Looking at this, oh, that's neat. So by Sudoku, we know that 1 and 2 are forbidden here and there, but because this is a 1-2 pair, this can't be a 1 or a 2. So these 3 digits are worth at least 3, 4, and 5, and actually they can't be 3, 4, 5 because there's a 4, 5 here. So this is at least 3, and the remaining digits are worth at least 4 and 6 to keep the possibility of having a 5 here. So this is at least 13, so this is at most 8. So there has to be a 1 here or there. There is a 1 here or there. The ways of having a sum of 8 are 1, 2, 5, 1, 3, 4. This is not 1, 2, or 3, so this is 5 or 4. And those are among 1, 2, and 3. That's some restriction. And now this is at most 8, but this is at least 7, because this can't be less than 4. This can't be less than 1 and 2. So the sum is either 7 or 8. So here it's either 13 or 14. So it has to be something along those lines. It could still be a 6 here, actually. So it can be 3, 4, 6, or 3, 4, 7, or 3, 5, and 6. This is how it goes. So 3 has to go either here or there. And the remaining digits must be among between 4 and 7. So this one is 3, 6, or 7. This is between 3 and 7. This is between 3 and 7. This is between 4 and 7. There has to be an 8 among those digits. Okay. And the fact that this is 4 or 5 forbids this 9 sum to be 4 plus 5. So that's one less possibility. So it must be, no, it can't be 5 plus 4 or 4 plus 5. So it has to be 6 plus 2 or 7, 6 plus 3 or 7 plus 2. And now we have a 1, 2, 3 triple. Nice. And how does this interact with this digit? If this is a 2, then we must have 3, 1, and 2. And this must be a 5. So let's have a look at this left-hand scenario. This left-hand scenario is really 2, 3, 1, 2. Oh, but this can still be 4 or 5 actually. And this one makes, on the right-hand scenario, still has the possibilities of 2, 3. Well, that's not so helpful. But now I know there's a 3 here in one of those cells. There's some degree of freedom here. I know that this is not 1 or 2, and I still need the digit, the companion digit of this one, and it's not here because of that. It has to be somewhere here, but here it wouldn't work because those two digits must add up to 12. So the remaining digit is actually here, the missing 1 or 2, and 8 must be either here or there, together with the digit which is not taken here, between 3 and 7. There must be an 8 in this column, but I don't think I can see where it is. Now we know that those two digits are the same. And in this box, this digit must be somewhere on this row, but I don't see the restriction. Is there something here? I was thinking about this 1 or 2, this 2 or 1. In this box, it's not here, it's not here, it's not here. So it has to be in one of those cells. Here it would work. 2, 2, 1, and 6. 1, 1, 2, and 7. 2 or 1 here would make this a 6 or a 7. That would totally work. This digit here would work as well, I think. Not sure. What about this? Is there any new restriction? I can't see it, if there is. 1, 2, 3. Let's remember that, oh yes, this is either 8, 7 or 8, 6. So we have an 8 and a 6, 7, 8 triple here. So this is a 4, 5 pair together with this one. What do we have next? There's also a pair of digits between 6, 7, 8. Do we have a restriction? Oh, this is also 1, 2 pairs, so these digits can't be 1 or 2. It has to be 5, 4, or 3. And in return, this one is either 4, 5, or 6. And those two have a sum of 8. A 5 here would really be a big restriction. It would force those to be a 6 and a 3. And this, let's have a look. 5 here would make this a 3, this a 6, this a 7, this a 2, this an 8, this a 6. And now 8, 6 would come with a 2 here. Oh, and it wouldn't work. It wouldn't work because those would have to be 1s. Those two are incompatible. So this can't be a 5. We need those to have a sum of 8. So this can't be a 3. This can't be a 3, so we have a 3 in one of those cells. Not sure it has a big impact, but is there any option we can rule out? 4. Actually, 4 would have the same effect. 4 would make this a 3. Actually, these being 3 plus 6 would have the same effect. 3 and 6 here would have the same effect. I mean, it would make this a 7, this a 2, and it's even worse. 7 here and 2 would make this a 2, would make this a 6, 8 pair, and this is the real impossible thing. So this is a 6 and this is a 3. And now we can remove 6 from here and 3 from that. So this is not only not 5, it's not 4 either. And I don't need to mark it. I know this is a 4-5 pair. And now this being a 6, we have 7, 8 here. And now this is a 1-2 pair. And we can continue with the synchronization of the 1-2 pairs. Meaning, for example, that this sees both digits and it can't be 1 or 2. Same for this one. Same for this one. Actually, this 1 or 2 must be here or there, which doesn't seem to really help a lot. What do we have next? So there's still something to resolve here. Oh, we now know that this digit, this 1 or 2, is not here. It's not here, so it has to be in this cell. And this is a 3, and this is a 3. And this doesn't help for this disambiguation, but that's something. There must be a 3 around here, but I don't know where. what is... Oh, now this 2 or 1 must be here. And by Sudoku, it has to be here. It has to be in one of those cells. Something tells me that here it would hardly work. If I put this 2 or 1 here, what happens? This makes either 4 or 5, 4 on the left hand, 5 on the right hand. So this has to, these two digits must have a sum of 16 or 15. And it's still possible with double 8 or 8 and 7. So this is not ruled out. Oh, but now this 11 on the right hand side, 2 plus 2 plus 1, on the left hand side, sorry, that's a 6. On the right hand side, that's a 7. Right hand scenario, left hand scenario. This 7 makes this an 8 and this a 7. Oh, and what about this? I didn't pay attention to that. This 5-4 is actually not synchronized with the 1-2s, I think. That's just something I wrote down this way. But now this is 3, this plus this is 12, so this has to be 7 or 8. Together with this. What about this row? This 6, 7 is synchronized with this. This digit plus this digit have a sum of 8. This now, oh, this now can't be 1 or 2, 3, 4, 5, or 9. This has to be 6, 7, or 8. So we have a triple here. There's a 6 in one of those. And now those digits must be between 1 and 5. So this one could only be a 3. So now I have a 3 here. And a 3 in one of those cells. This one can only be a 4 or a 5 because of this, and it's the same digit as this one. I have to be careful because those ones and those ones are not synchronized. So I must really be careful not to think that this 5 must come with this one or something like that. But now this is 1 or 2, synchronized with all these 1s and 2s. And 6 is not here, it's in one of those cells. Oh, the missing 3 is here. So, what do we know about? Is it time to look at this 25? Oh, on this row, we need an 8. It has to appear here, so this is not an 8. So this is an 8. and this is 6 or 7. And now I can synchronize the 4s and 5s. This one is synchronized with the 1 and 2s, so this one is 4, 5, this one now is synchronized, and I synchronize those ones here. And those are not synchronized for the time being. I still need 6, 7, 8 in these cells. And now I know that this is 5 or 4. And it's synchronized as well. Now this 21 should be very restricted. We have 3 here, plus 3, that's 6. So these 3 digits must have a sum of 15. And there are several ways of doing this. 6 plus 5 and 4, 7 plus 4 plus 4. Well, not sure what to do about this, but we really must be near. And let's remember that these digits must add up to 12. There's something here about this. That's 12, that's 15. Yes, we know the sum of those 3 digits. Because this is 12, this is 15, so that's 27. But those add up to 9, so those add up to 18. 18, with 3 different digits. It can be 7, 6, 5. And it can also be 8, 6, 4. But 7 here wouldn't work, because then those would, yes, this with a 7 wouldn't work. Those should then add up to 11, and 7 is not available. So this one is a 6. So this one is 7, this one is 6. And now, because of this 8 and this 6, we know that this one is a 2. And the dominoes should all fall. The 1s and the 2s now are resolved. And that's a 5, that's a 4, 5, 4, 5. And this is a 4, this is a 5. What next? I don't want to rush it. This row needs a 6. It has to go there. This is 7 or 8. We need a 4 here. Let's have a look at this 21. So now this is 14. This must be 7. So this is a 4. That's a 5. So this is a 7. That's an 8. It places a 7 here. This 21, this 15 are now okay. Now here 11 requires a 6. 11 is done. This 31 is good. This 7 makes this an 8, this a 7, this an 8. What about this? This 25, 14, 22, so we need another 3. It has to be this way. Oops. So that's a 7, that's an 8, that's a 4. It all seems to work. And this 20, it works. So I think the end should collapse pretty quickly. Where do we put the remaining digits? What do we need? We need a 7 on this row. It has to go there. This is a 7. This is 8. That's a 6. That's a 6. We still need 5 and 8 here. So this is 5. This is 8. What next? 4, 6, and 7. Also, that has to be 4, 7, and 6 in this order. Then these are 4 and 9, and this is 5. Next, 5 here, 9 there, 7 here, 8 and 6 on the top. That's 6, that's 8. This is 9. We need a 2 and a 5. 4, 5 here, 8 and 9, 9 and 4. This all seems to work. Now I'll type the solution code on Logic Masters Deutschland. So I hope it's worked, but I'm confident. And oh, is it working? It's working, yes. Fine. I'm the 4th solver of this puzzle, and I'm very glad I am. So this was definitely a hard puzzle, and this was definitely a very nice puzzle. Very well set. I really loved the opening with those sums, the degrees of freedom, and then the rest of the puzzle was still challenging. This is very, very well constructed. Thanks for watching this video, and see you later on Sudoku.